So shaft support two pulley at free ends, and it's also support on two bearing. The shaft transmitting a 7.5 kilowatt power and having an RPM of 360 RPM from pulley 1 to pulley 2. Also, the diameters of the pulley 1 and 2 are given as 250 mm and 500 mm, and the respective mass is also given as 10 kilogram and 30 kilogram. The belt tension act vertically downwards, both the pulley having a tension vertically downward. So it's also given, and the ratio of belt tension, both the pulley will be having a tension, right? There will be tension on the side side and the slack side. So both the pulley will be having same uh, belt ratio, that is 2.5:1, and the shaft material having yield strength of 380 megapascal and factor of safety is given as 3. The length of the shaft is also given as 1000 mm. And the distance between pulley and bearing is given as 250 mm. We have to determine the diameter of the shaft. Okay, then now let's look at the solution part. So this is the figure according to our given condition. They have mentioned the pulleys are placed to the free end. That means at the most point of the shaft, and already mentioned there is a bearing, two bearings. So it's also this shaft is placed on two bearing point. So I'm calling the first pulley point as A, the bearing point as B and C, and the second one as D. The diameter of the pulley is also given. I mentioned the length of the shaft as 1000 mm. Always remember that we are not taking the length. If the length of the shaft means you are not taking from the one end to right end, it's always between the end to end distance between bearing. Okay, if length of the shaft means 1000 mm means that is the distance between the bearing B and C. You have to keep that in mind. They are already mentioned the distance between the pulley and bearing is 250 mm. Since it is symmetrical, both the pulley and the bearing will be having a distance of 250 mm. Okay, one thing you have to remember is length of the shaft means always bearing to bearing distance. Don't make that wrong. So 1000 mm means the distance between B and C. Okay, next I have written all the given condition, power, RPM, diameters, mass, and all that thing. So before proceeding, we have two pulley. So obviously each pulley having two tension, one on the tight and slack side. So I'm calling 1 and 2, T1 and T2 be the tensions on the first pulley, and T3 and T4 be the tension on second pulley. Whenever taking T1 and T2, T3 and T4, it's always T1 bigger and T3 bigger on it's as an understood thing. Okay, when we're taking the ratio, the upper one will be having the higher value. That's always we assume. So T1 by T2 and T3 by T4 are 2.5. Okay, now let's look at the vertical and the horizontal diagram. You can see, looking at the vertical diagram, at the point A will be having uh, since they have mentioned the tensions are along the vertically downward direction, T1 and T2 will be in downward direction. If that sometimes will be mentioned like a horizontal drive, that the power will be transmitted horizontally, then you have to take that in the horizontal diagram. Here they have already mentioned both the pulley will be having tension along the power transmitted along the vertical diagram. So that is the reason T1 plus T2 is taken the downward direction. Along with it also has a weight. So at point A will be having T1 plus T2 as well as WA. Point B will be having point B and C are bearing point, so it will be having the vertical component of reaction at point B, as well as there will be vertical component of reaction point C. So that's the case of B and C bearing points. Similar case at point D also, that pulley will be having T3 and T4 is vertically, I mean they had mentioned this in vertical downward direction. So T3 and T4 along the weight of the pulley D. This is all about the vertical diagram, but actually here the horizontal diagram is relevant because it's not the relevant. We'll be only having RBH and RCH, the horizontal component of reaction force of both the bearing. So we cannot it's not point in taking a horizontal diagram because we cannot equate it with the, because there is no moment at that um, by taking the horizontal diagram. So we'll be focusing on solve this problem by vertical diagram. Okay. So now we have to find the torque. Okay, the general torque of the shaft will be we can find by using this equation 9.55 into 10 raised to 6 p by n. That will be 1.98 into 10 raised to 5 Newton mm. But you need to find the individual tension on both the pulley considering the first pulley, that the torque, the shaft torque will be equal to the pulley torque. That torque will be caused by, so that the torque on the pulley, first pulley, will be due to the difference in tension on that pulley into that radial distance. From that you get the T1 minus T2 is 1584. We also know the relation between T1 and T2 is given in the question. So now we get the value of both T1 and T2 of the first pulley. Similar way you can find the second pulley in same way. So that's the general assumption, since these both the pulleys are based on the same shaft. Torque TA and TAP are assumed to be same. I mean, torque on both the pulley are assumed to be same. So that same value can be used here not to find T3 and T4. Okay. So considering the vertical loading diagram, I'm taking we have point B and point C as a bearing point. So that point the moment will be 0. So I'm taking MB to be 0. You can either take MB or MC as 0. Here I'm taking MB to be 0. So taking the moment about that point, you can see all the, I mean, the anti-clockwise, the moment and clockwise will be opposite sides of the equation. So this is according that this will be the condition. From that, we can find the value of RCB. Okay, here WA is the weight in Newton. We have only given the mass. The question we have only given the mass of the pulley, so we have to convert that into weight. So we have to, that means weight equal to mg. So mass into, you have to multiply with the acceleration due to gravity, not to find the weight W and WB. So RCB we will get it as 1729.37 Newton. Next, you need to find the moment, that MAV and MDV, that will be 0. Okay, that vertical moment at the point A and D will be, there's no other force causing moment along that at that point, but there will be moment, vertical moment around MBV and MCV, right? For MBV it will be caused due to T1 plus T2 plus W. I mean, that net force of T1 plus T2 and W will be causing moment at point B. We are talking about only the vertical diagram. Okay, similar way MCV, that moment will be caused due to T3 plus T4 plus WD into 250. Okay, so maximum bending moment will be, so we have to take in since we are not considering the horizontal diagram, it's not relevant, because there's no point, because we cannot find any moment by taking horizontal diagram. So only need to take the vertical load diagram. So in vertical load diagram we got both MBV and MCV, the only 2 point having moment. So not to solve this cyber problem, when we're having 2 moment we have to take the maximum moment. So when this the maximum moment will be MBV, that will be 94 8500 Newton mm. Okay, so according to maximum normal stress theory, this is the equation, because we have given the value of uh, normal stress in this question. That means we have to take only the normal stress theory. Here the CM and the CT value to be assumed as 1.5 and 1. Since we are given the not direct the normal stress value, they are given only the yield strength value and factor of safety. You need to find the maximum normal stress value as yield strength by factor of safety. So now you have the value of maximum normal stress values 126.66 megapascal. Final step is all you have to do is to substitute in the equation, and the final part is just substitute in the equation, and you get the value of 38.6 mm. But we cannot take the value of 38.6 mm as the diameter of the shaft. You should always write it the standard diameter of the shaft. So there's a page in the data book, you can find the standard diameter value. So based on that, next standard diameter value will be 40 mm. So diameter of the shaft will be 40 mm. So this is the way to solve this problem.